everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In last class, we completed our discussion on emitter biasing and fixed biasing. Now in this class, we will study voltage divider bias, which is our last topic for biasing techniques. Now let us discuss voltage divider biasing. This is the circuit for voltage divider biasing. In this, we can clearly see that we have four resistors connected in a manner RC, RE and R1. We already discussed this in our emitter biasing. Now, a fourth resistor here is R2, which is connected in parallel with R1. So, here we can see that we have current I1 which is coming in this circuit and it is flowing towards the resistor R1, and this current I1 is further divided into two currents. First one is IB which is flowing in this direction and the second one is I2 which is flowing in this direction. So I1 is nothing but it is addition of I2 plus IB. Now we know that base current is very less. If we talk about the junction here, the base current is very less. So if we neglect the base current, then I1 is similar to I2. So this is our first observation, that current flowing through resistor R1 and resistor R2 are same. Now the second thing is that this section we are considering as input side and this is output side. So we will apply the voltage equations in the loop. Now here I roughly draw the circuit diagram of voltage divider. Now we will do the circuit analysis. First we have to consider this voltage point, which is nothing but VB or base voltage here. If I calculate the value of this VB, we have to make the KVL equation of this loop. So we are applying the KVL in this loop. So VB is nothing but this voltage we already know, VBE, which is base emitter voltage, plus VE, which is nothing but this emitter voltage. So VB is nothing but VBE plus VE. Now if I have to calculate the value of VE from this side, emitter voltage, which is nothing but VBE minus VB. So this is the emitter voltage. If I have to talk about the emitter current IE, so we know that the voltage and current relationship from Ohm's law, V is equal to IR. So the value is IE is equal to VE upon RE. Okay, RE is this resistor. From this equation, we can clearly see that IE is VB VE upon RE. So here the value of IE is nothing but IC plus IB. So IB is very small in nature. So we can simply consider IE as IC. Okay, so these are equal. Now we have to take the value of IC from this equation. So IC is nothing but VE upon RE. Okay, and VE potential, we already calculated VE potential, which is nothing but VB minus VBE upon RE. So from this equation, we can clearly see that IC is nothing but VB minus VBE upon RE. In this case, we can clearly see that the IC is independent of beta. So stability of that circuit is very high. Let us consider for the output loop. So in output loop, if we apply KVL, what we will get, VCC equal to ICRC plus VCE plus IERE. Okay. In output loop, if we are applying the KVL, the equation will be like that. So from here we can calculate VCE, which is collector emitter voltage, is nothing but VCC minus ICRC minus ICRE. If we take common here, IC common, then the equation will look like RC plus RE, similar manner. Okay. So in this equation also we can see that the VCE or the collector emitter voltage or the IC, the current is independent of beta. Okay, if we calculate the value of IC from this equation, what we will get? We will get VCC minus VCE upon RC plus RE is nothing but IC. So from this equation also we can clearly see that now IC is independent of beta. It means beta is no more related to IC. So in the case of voltage divider, the beta IC is independent of beta. It means IC is independent of transistor parameters also. So the stability factor of voltage divider is the best among all of the three. So in this class, we completed the discussion on voltage divider biasing. In voltage divider biasing, we connected the resistance R1 and R2 in particular manner so that the voltage is divided in the both resistance and the current flowing towards the towards the junction towards the resistance is same. So in this class, we completed our discussion on biasing techniques of the transistor. Now we will discuss few more topics in our next class. Till then, thank you so much.